Good morning all. So in today's class we will see one more problem on bijection principle. So the question is, so a student wishes to walk from the corner X to the corner Y through streets as given in the street map. So you have a figure given here. So you need to go from X to Y. How many shortest routes are there from X to Y available to the student? So here the corner points are X and Y. So here this corner point is X and the corner point and Y. You need to find out how many shortest routes are there from X to Y. And now we will find this using the bijection principle. അപ്പോൾ നമുക്ക് set of all shortest routes and corresponding ആയിട്ടൊരു bijection form ചെയ്യണം. So let us define A to be the set of all shortest routes from X to Y. So our aim is to find what is cardinality of X. Here if you look at any route from X to Y, അപ്പം നമുക്ക് X നിന്ന് Y യിലേക്ക് പോകണമെങ്കിൽ we have to travel both vertically and horizontally. അപ്പം vertically നമ്മൾ 3 സ്റ്റെപ്സ് എപ്പോഴും എടുക്കണം, എന്നാലേ നമുക്ക് മേളിൽ വരെ എത്താൻ പറ്റുള്ളൂ. അതുപോലെ ഹൊറിസോണ്ടലി എപ്പോഴും 4 സ്റ്റെപ്സ് എടുക്കണം. സോ എവറി ഷോർട്ടസ്റ്റ് റൂട്ട് വിൽ കണ്ടെയ്ൻ 3 വെർട്ടിക്കൽ പാത്ത്സ്. വെർട്ടിക്കൽ ആയിട്ട് നമ്മൾ 3 തവണ പോകണം, അതുപോലെ ഹൊറിസോണ്ടൽ ആയിട്ട് 4 തവണ പോകണം. സോ എവറി ഷോർട്ടസ്റ്റ് റൂട്ട് വിൽ കൺസിസ്റ്റ് ഓഫ് ദാറ്റ്. So every route in A will consist of 7 continuous segments. For example, if you look at this, the darkened portion കാണിച്ചിരിക്കുന്നതിൽ, so here you have vertical, then 2 are horizontal, again 2 vertical, 2 horizontal. So if I am taking like this, ഈ എൻഡിൽ കൂടി പോകുന്ന പോലെ എടുക്കുകയാണെങ്കിൽ again 3 vertical and 3 horizontal. So if I go this way, 4 are horizontal, then 3 are vertical. So every shortest route will contain 4 horizontal and 3 vertical segments. Now let us use 0 to denote a horizontal segment and 1 to denote a vertical segment. Upon any route can be expressed in terms of 0 and 1. So 0 will denote a horizontal segment and 1 will denote a vertical segment. ഇനി നമ്മൾ ഏത് ഷോർട്ടസ്റ്റ് റൂട്ട് എടുത്തു കഴിഞ്ഞാലും അതിൻ്റെ അകത്ത് എപ്പോഴും 0 will occur 4 times and 1 will occur exactly 3 times. So every route can be considered as a binary sequence which contains 7 places and which is containing exactly how many 4 zeros and 3 ones. So every route in A is unique binary sequence of length 7 with 4 zeros and 3 ones. So this gives us a bijection. So every route has a bijection with the set of all binary sequences of length 7 which is containing exactly 4 zeros and 3 ones. So I'm mapping F from A to the set of all binary sequences of length 7 with 4 zeros and 3 ones is a bijection. And now the length of binary sequences of length 7 with 4 zeros and 3 ones. അപ്പോൾ 4 zeros ഉം 3 ones ഉം വേണമെങ്കിൽ നമ്മൾ ആദ്യം സീറോസ് അറേഞ്ച് ചെയ്യുക. So ones will be arranged automatically. So that can be done in 7C3 ways. So we have seen this earlier. So therefore cardinality of A will be equal to cardinality of B by bijection principle. So that is equal to either 7C3 or 7C4. So the required number of shortest routes will be 35. So we can generalize this result. So in general, if it is an m plus 1 into n plus 1 rectangular grid consisting of m plus 1 vertical streets and n plus 1 horizontal streets. Then the number of shortest routes from the southwest corner x to the northeast corner y is equal to, so that will be equal to m plus n etra vertical routes ആണ്, എത്ര horizontal routes ആണ് വേണ്ടത് നോക്കുക. So the number of shortest routes will be m plus n cm, or that is equal to m plus n cn. That is the required number of shortest route. So this is an example of the bijection principle. Now let us see, let us move on to the next topic. Next is, അപ്പോൾ നമ്മൾ ഇത്രയും നേരം കണ്ട് പെർമ്യൂട്ടേഷനും കോമ്പിനേഷനും there, that is the number of arrangements. Permutation എടുത്തു കഴിഞ്ഞാൽ, so when you write NPR, that is the number of permutation of n different objects taken r at a time without repetition. So out of n you are arranging r objects and repetition is not allowed. അതുപോലെ കോമ്പിനേഷൻസിന്റെ കേസിലും when you find NCR, that is the number of combination of n different objects taken r at a time without repetition. So out of n you are choosing r objects and repetition is not allowed. So now we will see different arrangements and selections where repetitions are allowed. So in today's session, so we will see one such result. So the number of r permutations of a set A equal to a1, a2, etc. an, where r comma n belongs to n, with repetitions allowed is given by n raised to r. So here you are given n objects a1, a2, etc. an. So we are asked to find the number of r permutations. അപ്പോൾ a1, a2, an നിന്ന് r objects choose ചെയ്യണം, r objects arrange ചെയ്യണം. In this case repetition is allowed. അപ്പോൾ നമുക്ക് r places ആണ് fill ചെയ്യാനുള്ളത്. അപ്പോൾ first placeൽ എനിക്ക് എല്ലാ n objectsഉം place ചെയ്യാൻ പറ്റും. ഇനി അതുപോലെ second place repetition allowed ആണ്. repetition allowed ആയതുകൊണ്ട് again all the n objects can come to the second place. അതുപോലെ rth placeലും repetition allowed ആയതുകൊണ്ട് എല്ലാ n objectsഉം place ചെയ്യാൻ പറ്റും. So therefore by multiplication principle the number of r permutations with repetition allowed will be given by n raised to r. അപ്പോൾ the proof is what we have said just now. So there will be n choices for the first object of an r permutation. Now since repetitions are allowed, there are again n choices for each of the remaining r minus 1 objects of an r permutation. So by multiplication principle, the number of such permutation will be n into n, etc. n. r times you are taking the product, so that will be n raised to r. And we will see an example of that. So a 4-story house is to be painted by some 6 different colors, such that each story is painted in one color. How many ways are there to paint the house? So you have a 4-story house and you have to paint each story. So there are 6 possible colors. Colors mix ചെയ്യാൻ പറ്റില്ല, ഓരോ സ്റ്റോറിക്കും 6 കളേഴ്സിൽ ഏതെങ്കിലും ഒരു കളർ വെച്ച് പെയിന്റ് ചെയ്യാം. So for the first, there are 4 stories for the building. Okay, so for the first story you will have 6 choices, and for the second one again 6 are there because repetition is allowed. ഏതെങ്കിലും കളർ യൂസ് ചെയ്യാമെന്നാണ് പറഞ്ഞിരിക്കുന്നത്. For third also there are 6, and for fourth also there are 6. So this is the permutation with repetition involved. So therefore the number of ways to paint will be equal to 6 raised to 4. So that is the required number of ways. So in the coming classes we will see a few more arrangements and selections where repetitions are allowed.